got it. And I have an error message now.
No, you're good. We're good. Go.
What happened? Are we live?
Yes.
Are you sure?
Well, hello, everyone, and welcome. Thank you so much for your patience as we sorted out a couple of technical things there. Welcome to Ask an Astronomer. My name is Cynthia, and I work with the BC Summer Reading Club. Our theme this year is space, and we are delighted to be teaming up with our friends at the HR MacMillan Space Centre to explore our universe. And we gratefully acknowledge our funders, the Ministry of Education Libraries Branch and QPBC, for their generous support. The BC Summer Reading Club is sponsored by the BC Library Association, and we are privileged to have our office and to be presenting this Ask an Astronomer event in the city of Vancouver, which is located on the unceded territory of the Coast Salish peoples, including the territories of the Musqueam, Squamish, Stolo, and Tsleil-Waututh nations. And now let me turn things over to Trish and to Rachel.
Everyone, thanks very much for joining us this afternoon, and thank you for your patience while we sorted out our tech issues. And I'm super excited to be here with Rachel, our astronomer from the HR MacMillan Space Centre, as we celebrate reading, we celebrate books, and we celebrate a summer of exploring the universe. And Rachel, I have to say, this summer, even though technically it's only a few weeks old, we have really launched into a lot of great things up in the nighttime sky. So
yeah, there's so much stuff.
There's so much stuff going on. I know you've been really busy, and I know you've even had a few nights where you've gotten up super early or stayed up really late to see something special in our nighttime sky. And I know you're going to talk about that today. So without further ado, let's get started into our presentation, and I will just stop my video for now. So take it away.
For sure. So I'm just going to quickly share my screen here. So I'll start off with a little bit of explorers of space, talking about the ISS, the moon, and Mars. And then I'll talk a little bit about what we can see in the nighttime sky, and then hopefully go into a question period. So here we are, we're starting at the Earth with the ISS. So imagine you are stuck in a 6-bedroom house with 6 of your friends in orbit around the Earth for months at a time. You would get to float because of the microgravity conditions and could see Earth from space. And if that sounds good to you, then you'd make a great astronaut, because that's essentially what astronauts are doing on the ISS right now as they orbit above us in space. So here you can see astronauts experiencing the microgravity of space, and this is what you would see through the window of the ISS. But before sending people to space, NASA does Earth-based missions that scientists run as a test before running their actual mission, because we all know that practice makes perfect. And they run these tests in places here on Earth that look and feel similar to the extreme space environments that astronauts and robots encounter on their missions. Places like the desert, which look a lot like the surface of Mars. Now, hot and dry places like deserts are great for running these analog or test missions for going to the moon and Mars. These test runs are really important for space agencies like NASA and the CSA, because space missions are expensive. Not only that, if we're sending a rover or a human on a mission to outer space, we want to be 100% sure that they are safe. So during these test missions, they practice what it'll be like to live and work off of Earth, things like talking over long distances, not being able to use any of the resources that you have on Earth, and only using what you brought with you to space. And then once you're ready, we can send robots and eventually humans to faraway places like Mars. Now, if we sent someone to Mars on a spacecraft, this is what they'd see. They could visit some cool places on Mars, and let's visit a few of these places. One of them is called the Mariner Valley, and it looks like we land on the nighttime side here. Let's see if I can spin it around and maybe brighten up the planet. There we go. So this is the Mariner Valley. It's a huge canyon on the surface of Mars, kind of like the Grand Canyon. It's so big that we could fit all of Canada in it. It started as a crack in Mars' surface billions of years ago and got bigger and bigger as the planet cooled. You could also go to Olympus Mons, which is a massive shield volcano that's almost 3 times as tall as Mount Everest. Now, Olympus Mons couldn't exist on Earth either. With Earth's stronger gravity, this massive volcano would collapse under its own weight if it were on our planet. Or maybe you'd like to visit the polar ice caps. Scientists are really interested in studying these caps because they have a lot of water stuck inside them. So if humans are going to live on Mars, we'll need a source of water. So this is a great place to start looking. Now, over the years, NASA has sent 4 robots to Mars. Their names are Pathfinder, Spirit, Opportunity, and Curiosity. And you can see where these robots have landed with these markers. And what's exciting is that NASA is sending another rover to Mars in the coming months. And its name is Perseverance. And it'll be launched on the Mars 2020 mission sometime between July 30th and August 15th. And the main job that Perseverance is sent there to do is to look for signs of ancient life and collect rock and soil samples to study back here on Earth. This will help us figure out whether humans could live on Mars one day or not. So I'm personally very excited to see what Perseverance will find on the red planet when it lands there early next year. Now, if you're a fan of eating space food and being able to float, maybe you don't want to travel as far as Mars. Maybe you'd like to be on the next mission to the moon. It's called the Artemis 3 mission, and it's set to happen in 2024, so just 4 years from now. The last time humans went to the moon was way back in 1972, almost 50 years ago. So this will be our first time back since then. And not only that, NASA has promised the first female will walk on the lunar surface with this mission. Now, NASA wants to go back and build something really similar to the ISS, something called the Lunar Gateway. It'll be an ISS-like space station that orbits the moon instead of the Earth. The mission is called Artemis because in Greek mythology, Artemis was the twin sister of Apollo. Now, you might wonder, well, humans have already been to the moon. Why do we want to go back? And that's a very good question. Well, having a space station orbiting the moon will allow scientists to pop down to the lunar surface whenever they please to collect samples and conduct science experiments. Also, learning about the moon will help us prepare for traveling to further or deeper space destinations like Mars. Now, I see that you guys have sent in some questions, but before I get into that, let me talk a little bit about what we can see in the nighttime sky, because as Trish said, that there are a few really cool things that we're able to see. And the one that I saw was last Friday, and that was Comet Neowise. And let me just quickly stop sharing my screen here. And Comet Neowise was in the news a lot because it's a really bright comet. You can actually see it with your naked eye or even a pair of binoculars. And it's on its way around Earth, and then it'll head outside of our solar system, and you will only see it, or it'll come by again in another 6,800 years. So a few thousand years till we can see this planet again. So it really, or this comet again. So it really is truly a once in a lifetime thing to go see. So I'd highly recommend anyone, if you want to go try to see it tonight or even in the next couple of days, you want to go just after sunset, an hour after sunset, in that 10 to 11 p.m. mark. You're going to want to locate the Big Dipper. Looks like a big question mark in the nighttime sky. And then just under the Big Dipper is a constellation called Lynx. And you'll be able to find it because it looks like a big zigzag across the night sky. And that is where the comet is right now. And what I use to help me is I use an app that I can point at the nighttime sky, and it'll tell me where the constellations are and what constellation I'm looking at. And we also
Rachel, that's a really good question. And that kind of lends us to the question that's coming in online is, what's the difference between a comet, a meteor, and a meteorite? If you could spend a little bit of time explaining that to our friends across the province.
Sure, that's a really good question because a lot of people think that they all kind of sound like they describe the same thing. So I'll start with a comet because we're talking about Comet Neowise. And a comet is essentially a dirty snowball. So it's made out of chunks of rock and ice. And as it flies by our sun, the sun heats up that ice. So we start to see a dust tail forming. So it kind of looks like a feathery trail that trails behind the comet. So that's what you'd be seeing if you went out to see the comet. Now with a meteor, you're really talking about this chunk of space rock. And when it interacts with our atmosphere and starts to burn up a little bit, becomes a meteorite. And when you find it on the Earth's surface, then it becomes a meteorite.
That's really cool. So if somebody's talking about being out in the summertime and seeing a shooting star while they're waiting to see the comet, what have they actually seen?
So they've seen a meteor. So that is what we commonly would say is a shooting star. But I always like to joke that it really could be space poop from the ISS that burns up in the atmosphere that they're trying to get rid of.
That's right. Now, Kevin has a question. So how are you able to see this comet? Can you see it with your eyes, or do you need a telescope like the big one in the observatory behind you?
That's a great question. So you should be able to see it with the naked eye. I was able to see it last Friday, but it is getting dimmer every day. So you want to go as soon as possible. And what I did actually is I used my peripheral vision. So what I did is I didn't look right at the comet. I actually looked a little bit to the right or a little bit to the left of the comet. And that's because you have special cells in your eyes that are more sensitive to dim light in your periphery. So you want to look a little bit to the side of the comet. But of course, if you have binoculars or even a telescope, that'll help you see the comet even clearer.
Now, that's a good question, because why is the comet getting dimmer? Is it because it's melting?
Yeah, so it should be bright. So comets are really dynamic things. You know, they're kind of, I'm going to say temperamental. They can disintegrate. All sorts of things can happen to them. But because it had its nearest approach to the sun on July 3rd, that's when we would have seen that peak brightness, because the sun is melting a little bit of that comet and causing it to almost shine very, very brightly. But as it's moving further and further away from the sun, it's going to start getting dimmer and dimmer.
So it is going away from the sun now, because that was a question someone had online. Is it going to crash into the sun?
No, so it's on a very extreme trajectory. So it's not a circle, but it's almost like if you took a circle and you stretched it all the way out. So it's coming from outside the solar system, flying by Earth for a nice visit, and then it'll shoot right back out of our solar system.
Wow, that's really cool. Now, do we have any idea how big it is? So if someone was going to measure it with a tape measure, how big is this comet we're seeing?
It's definitely on the scale of kilometers, I believe.
Oh, wow.
When they measured it with NEOWISE, which is the detection or spacecraft that they named it after, I think it was around 5 kilometers across. So it's quite big.
5 kilometers. Oh my goodness. So you would need a pair of skis to head across that snowball comet flying through space. Massive. Okay. Really cool, Rachel. That's some awesome stuff. We had a lot of questions that came in today, and I didn't know whether you wanted to start answering some of those, or tell me what you think works best for you.
Sure. Yeah, we can just jump straight into the questions. I had answered a few questions that were sent in earlier. Maybe I can do a couple of those, and we'll jump into some live questions.
Brilliant. All right. Let's answer some of those questions that came in before. Sure. And then I've got a great bunch of questions that have been coming in the chat on YouTube that we'll get to too. And thanks for the shout out, Trail Library. I see your emoji there, so thanks for posting.
Awesome. So I'm going to start with why can we see the moon during the day? Because we just had an event here at Telescopes 101 where we had daytime moon viewing. And the reason why we can see the moon during the daytime is because if you take a look at the moon on the screen that I'm sharing here, it looks very white. And white reflects a lot of light. You probably know this. If you wear a white t-shirt out in the summer heat versus a black t-shirt, you'll be a lot warmer in the black t-shirt. So it reflects the sun's light, and so that's why we can see it during the day. And the next question is, when will be the next supernova? Well, it's hard to say, but on average, we should see about 1 supernova every 50 years in a Milky Way-sized galaxy. And so I'm showing you a video of what a supernova will look like. So in a minute, oh, there you go. You'll see a brilliant flash of light. So that is a supernova. That is the star exploding outwards, spewing out elements into space.
Wow, that's cool.
And another question is, how do black holes form? And that's a really good question. So I'm showing you a black hole in the center of my screen here. And black holes form when you squeeze a huge amount of stuff, a huge amount of matter into a very small volume. So you could actually make a black hole if you squeeze a star that was 10 times the mass of our sun into a sphere the size of Calgary. So for stars, you need more than 15 to 20 suns all squished inside a small area to form a black hole. And this question I really love because it asks, are there other planets out there? I get this question a lot, asking if there are aliens on other planets. And so here I've just turned on a bunch of markers showing you the exoplanets that we've found so far. So you can see there's tons and tons of other planets outside of our solar system, just waiting to be visited by us. All right, and then I have
That's a
one last
great question.
one last question here, and that is, what advice would you give to kids who want to be an astronomer? And I would say that anyone can do it as long as you have a passion for it. And you can always start off with backyard astronomy with just a pair of binoculars or even just your naked eye. And the first thing you want to do is learn the constellations, like I'm showing you right here, because constellations help us map the nighttime sky.
And that leads us to a question that we had from Angeline on chat is, what is a constellation?
Oh, that's great. So a constellation is a group of stars that some body of people have decided that these are the 88 modern constellations. Now, of course, we do have other groups of stars, and we call those asterisms. You might know the Big Dipper is an asterism, a group of stars, so is the Little Dipper. And these are part of constellations Ursa Major, the Big Bear, and Ursa Minor.
That's cool. So it's really like a big game of connect the dots when we're up and looking up at the stars in the nighttime sky. That's one of my favorite activities to do when we're out in the country and away from the city lights, is looking up and see if I could make my own constellation and come up with a story about that. That might be something that our friends in the libraries can do this summer, is come up with their own constellation and then do some research in the library and see if you can find some books on different constellation stories. I know there's lots of them, Rachel. Do you have a favorite constellation in the nighttime sky?
Ooh, I'm quite a fan of Andromeda because you can see the Andromeda Galaxy as a little smudge right above it. And I think that's really cool that that's the most distant object that we can see.
That's really cool. And what's that really popular winter constellation that we like to see here in Vancouver? But I know everyone across the province can see it too.
Oh, you're talking about Orion?
Yeah, that's the one.
Yeah. You can see Orion's belt, which is very popular, and everyone was talking about it just last winter because Betelgeuse, people thought that it was going to go supernova, but unfortunately, it didn't go supernova, and it could go off anywhere from tomorrow to the next 100,000 years. So there's a long time to wait.
That's a really good point, because that leads us into a next question that a lot of kids have been asking online is, will our sun go supernova? And can you explain to us what exactly does supernova mean, Rachel?
Sure. So supernova is basically a very violent and energetic explosion. So that was that brilliant flash of light that you saw in that video that I showed you. And supernova are really important because they're so energetic, there's so much energy there, a lot of heat, a lot of stuff there, that they actually form the heavy elements that we have. So things like iron, the gold in your jewelry, all of that is formed in supernovae. And the supernovae, because there's so much energy, they can actually spread all of those heavy elements out into the universe and into things like your jewelry.
That's pretty cool. So someone also asked, will our sun explode and eat the Earth? Now, I've kind of heard that question before, but I wondered if you could give us maybe a better understanding of what that means.
Sure. So our sun has fuel that it burns, almost like wood for a fire. And eventually it's going to run out of that fuel. And when it does, it's going to swell up and expand into what we call a red giant phase. And we call it a red giant phase because it looks red and it's gigantic. It'll actually expand all the way out to the orbit of Mars. But we don't have to be too worried because that'll happen in around 5 billion years. We're only halfway through the sun's lifetime.
5 billion years. All right. So we've got a lot of time to figure out a backup plan.
Exactly.
Now, Charlotte sent in a question, Rachel, and I wonder if you can help us with the answer. Charlotte was wondering how many stars are in the sky. Now, I know that there's a tricky answer to that because we don't actually see all the stars in the sky, do we?
No, yeah, that's a really great question. And, I'll share with you, Charlotte, the fact that I learned in my first day in astronomy class at UBC. And that was, if you imagine going to the beach and feeling all those grains of sand in between your toes, and imagine how tiny those grains of sand are. There are more stars in the universe than there are grains of sand on the beaches of the entire Earth. So there's many, many, many stars out there. And in our Milky Way galaxy alone, we have anywhere from 200 to 400 billion stars. And there's billions of other galaxies out there. So it's really a crazy number to think about.
That's a really good point. So our summer reading club theme is exploring the universe. And really, we're talking about something that's huge, Rachel, aren't we? Because that's Finn asked that question of how big is the universe?
So our universe can be split into what we call the observable universe and then what we can't see beyond that. And we call it the observable universe because we know that light takes time to travel. It's the fastest thing in our universe, but it does take time for it to travel places. And how long it travels in a year is what we call 1 light year. Now, if you think about the observable universe, so ever since our universe formed, light has been traveling, and it's been traveling for so long that our observable universe is, I believe it's 96 billion light years across. So it's a huge, huge amount of space because light can travel super fast, and it's been traveling for a long time.
So Hayden asked the question about how many galaxies are in our universe, but do we really know the answer to that question? Have we seen them all?
No, so we did try to map our universe, and we found a lot of galaxies, but we didn't find all of them. And what's kind of interesting about this map is that it kind of looks like a bow tie because these are the only two directions that we've looked in. So it looks kind of like this. And that's our current map of our galaxies that we've seen.
So there's all the other parts up at the top and down at the bottom that we haven't even looked yet. We haven't been able to. So what are astronomers hoping to do? I know we have a whole lot of telescopes that are all across the world, and I know that they're discovering new things all the time. So what are astronomers really looking for in the coming years?
So the big thing that's coming up is the James Webb Space Telescope. And we're really excited about that because it's supposed to be the successor to the Hubble Space Telescope. And Hubble brought us so many beautiful images of faraway deep galaxies that we didn't even imagine were going to be there because Hubble was pointed at this blank patch of sky. So we thought that there would be nothing there, but instead we found so many galaxies. And what JWST, or the James Webb Space Telescope, is going to do is it's going to look even further than Hubble Space Telescope did. And so we're hoping that it can look far enough to see the first planets forming, to see galaxies forming, and see the origins of all these structures that we have in our universe.
That's really cool because Kevin asked a question online was, can we create a time machine? But these telescopes are almost like a time machine in that they're looking at light that was from way back. Is that correct?
Exactly. So that's what we call the telescope's look back time. And a really simple example of that is our sun. So our sun is really, really far away, but we do get light from the sun. And light takes 8 minutes to travel from the sun to Earth. And so if you think about it, if you had something really, really, really far away, we could detect that light really far away, and that would be almost like looking back in time.
That's really cool, Rachel. Now, I know we have some great viewing coming up, and I know you chatted briefly at the start about some apps that you use, but summer is a great time for all of our friends across the province to head out into the backcountry, go into the camping trips, go into their backyard, go into a park when it's dark with their parents and look up at the nighttime sky. Can you share with us some of those apps that help you find things in the nighttime sky?
There's many, so I'll share with you the one that I use that I really like, and it's called Skyview. And the reason I like it is because it has altered reality, meaning that I can point my camera or point my phone at any patch in the sky, and it'll tell me what the constellation is or where I'm looking. And it helps me find things like planets, things like satellites. And I really like that it kind of puts a map on top of what you're already seeing. But there's plenty of apps out there. There's things like Starry or Night Sky, Google Sky, Skyview Light as well. There's lots out there.
And that'll help us find planets, not only stars and constellations. Is that right?
Exactly, yeah.
So some of the questions that have just been coming in now are asking us about planets in the nighttime sky. So I know summer is great for seeing certain planets. Can you share with us some of those?
Yeah, so what's really interesting is that July is actually a great time of year, or for this year specifically, to look at the two biggest planets in our solar system. So that's Jupiter and Saturn. I know, me too. And it's really exciting because they're actually closest that they have been in a few decades. I think in 20 years, it's the closest they've been together. So it's really cool to be able to see those two gigantic planets so close in the sky to each other.
Now, will we be able to see them with just our eyeballs, or do we need some help with those?
Yeah, you'll be able to see it with the naked eye. Saturn is the furthest planet that we can see with our naked eye, so it just makes the mark.
And if I used a pair of binoculars or even a telescope, like the Fraser Valley Library has lending telescopes, which is awesome, what could my friends see by using a telescope? Could they see the rings of Saturn?
Yeah, so you can see that Saturn has little ears. That's what we originally thought they were.
Ears.
They described them as ears. Yeah, these rings. And then we eventually figured out that they were rings around Saturn. But you'll be able to see the ears of Saturn. And then also you'll see the 4 Galilean satellites. So they'll actually look like points of light. They'll almost look like little stars, but they're actually the 4 largest moons of Jupiter. And they'll be in a straight line right in front of the big planet.
Now, Rachel, I happen to know that you like the moons of different planets. And if I were to bring up Enceladus, would you have a few things you could share with us about that one?
Sure, I love Enceladus. And the reason I love Enceladus is because Cassini was my favorite spacecraft of all time. And Cassini flew by Enceladus and it sniffed Enceladus. Now, what does that mean? Well, Enceladus is this kind of snowy, icy ball that's floating in space. So it has a really thick crust of ice, and underneath, we think there's a liquid water ocean. And there's actually geysers that kind of go through the cracks in the ice and spew out into space. So what Cassini did when Cassini flew by Enceladus is it sniffed these plumes coming from these geysers, and it was able to figure out exactly what kind of elements, what it was made out of inside of Enceladus without actually having to drill down into Enceladus.
Boy, that's some amazing science going on. I love that, Rachel. All right, so we're going to look for Saturn. We're going to look for Jupiter. We're going to go out into our backyards in the next couple of days and see if we can see the comet that's out there. Anything else that we should look up to see and explore in our universe?
Yeah, so I'm looking forward to the Perseid meteor shower that's coming up. Yeah, so that'll peak in mid-August, around August 11th and August 12th is when you're going to see the most amount of meteors. Now, some of the meteors will be a little bit dimmer, so if you can go to a place where there's little light pollution, so to a dark sky location, that would be the best to view the meteor shower.
That's great. And that's a great opportunity for us to connect with some of our libraries across the province that are away from the city lights. So I'm thinking about some of my friends up in the Smithers Library, some of my friends in Hazelton and Terrace and Kitimat. I think it would be a great opportunity for them when they're out camping with their families to look up at the nighttime sky and think of some questions for us in August, because we are going to return for another Ask the Astronomer session specifically for our Summer Reading Club friends. And I hope in the next month that you're going to fill your libraries with all kinds of questions and wonders about the nighttime sky. And at that session, Rachel, we're going to talk a little bit more about living in space. So I know today we spent a lot of time talking about the universe and everything that makes up the universe, but I specifically would like to know about what if I was going to go live in space? What are some of the conditions that we're going to be like? What would it be like? Could I take my dog to space with me? Would I miss her? Could she come with me? So lots of opportunities for questions to come up in August as well.
I'm very excited.
Very excited as well. Cool. So keep your questions coming in. And here's our friend Cynthia back from the Summer Reading Club. Cynthia, I hope you have some questions and wonders for us in August as well.
Oh my gosh, that was so amazing, Rachel and Trish. Thank you so much. Be sure, as Trish said, to come back and join us for another Ask an Astronomer event. That's Wednesday, August the 12th, 2:30 to 3 p.m. And you can find the link at bcsrc.ca, the YouTube link to join. And be sure to check out that'll be perfect. We can talk all about Perseid meteor shower, and hopefully people will have had a glimpse of them before they join us.
Absolutely.
Visit bcsrc.ca to find out more fun things to do this summer. Thank you everyone for being here today. Thank you, Rachel, and thank you, Trish.
Thanks, everyone.
Hey, thanks everyone. Enjoy your reading. See you.